Hey there, guys, and we are back. So, a lot of things on the chopping block, obviously, but we are going to take a quick detour because this is something that I want to get done in order to move on to other things as well. So, let's get started talking about it. During the Steam Summer Sale, bought a game. I'm not sure whether or not I will be playing it on stream, but it is Tooth and Tail. There you go, logo right there, as you can tell from the thumbnail as well. And one of these things where I think it would be a good I think it's a good candidate to play on the arcade joystick, because the controls, as you can see here, to move the character are WASD, and the controls overall are pretty simple. It's an RTS, which is why I picked it up. I've tried a few RTSs in the past few months since I started streaming, trying to find a new one to play, since I haven't been playing the old ones I used to play. And it's one of these things where this one is simple enough to be played on the arcade joystick. As you can see, it's also, it has controls for a gamepad as well, an Xbox controller, etc., whatever you'd like to refer to it as. So one of these things that gives us that makes things easier for us, is what I'm trying to say. And frankly, it's an interesting idea because the gameplay basically revolves around kind of a character action game. So you have a character that you walk around the map, and you do not directly control your units that you build from your base. They basically follow your character around if you want them to, or otherwise stick around or attack stuff as you command. And since you're playing a character, that gives us an opportunity to take some of these buttons and do interesting things with them, which was the reason why I wanted to put this stream up. So looking at the buttons, and I'm going to bounce back and forth between gamepad and keyboard here as I'm talking. The select structure one, and actually I'm going to bounce back to the camera periodically as well. So WASD, obviously, WASD / the move pad over here, very straightforward. That's just our joystick. Here, I'll grab the camera. Joystick, again, I'll put a proper knob on the top of it, but very simple, very straightforward translation there. The next the next easy one to do is the cycle. Where is it on the gamepad? Select structure. There it is. So the select structure, Q and E on the keyboard, otherwise the bottom thumbstick on the Xbox controller. That one also translates very easily over to something we already have built, which is the bi-directional controller. So we swap that back and forth. That gives us our two buttons that we need for cycle right, cycle left. Again, it translates very easily over, and it's an interesting idea. It's not just multiple push buttons, click left, click right. It is something interesting as part of the controller. Next up, the build and sell buttons. Now, these ones I'm thinking of actually just leaving as buttons, as push buttons, just the same exact things we use on the rhythm games, just the big 3-inch push buttons. You don't hear it clicking right now because in order to get it off the frame, I had to take the micro switch out. Just the way this particular button was sitting. The other buttons, probably, it's been a while since I've taken them off, but I think they come off easily enough. But the way this particular one was sitting, it was easier to just take the micro switch out to get it off. But as I was saying, buy and sell, I don't really mind being these buttons. They're very simple, straightforward actions that are not particularly interesting actions, so I don't mind having a couple buttons on here. But like I said, I do want to do something special, and the first one that caught my eye was the burrow button. And whoops, I'm trying to go to the next page. So burrow is an interesting idea because you gotta hold it down, and it basically lets you teleport between your bases, is what it does. After a short delay, it has a casting time. You hold down the button, it has a casting time, lets you teleport to a base. And that one is interesting, in my opinion. because the whole entire holding down aspect gets me thinking of a couple things. My first thought was kind of a throttle, a self-resetting throttle. Put a torsion spring inside of a throttle so that it wants to push back on itself, and then you pump the throttle forward, and that starts your burrowing action. It starts casting, right? And that was an interesting idea. I like that one because kind of the shift forward on the throttle kind of simulates kind of burrowing down kind of motion here. I mean, one of those things. Just so you get my idea here. So we got a throttle here, right? And burrow down into the ground. Makes sense. I think I've decided against that only because a throttle, just one of these things intuitively, when you look at a throttle, it's supposed to be an analog device, right? So I don't know. It just didn't really, from a meta standpoint on what is a throttle, it didn't make sense to me to have it be a throttle. So I'm kind of leaning away from that. And I'm still kind of trying to figure out a solution on what to do instead. I did have an idea of, instead of being a forward throttle, one that you grab here and do this, having a sideward twisting throttle, that would differentiate enough that I think that it would break that kind of meta instinct on what the throttle is doing. But I wasn't really sold on that. The other idea I had, I actually I haven't abandoned it. It has gone to a better place, and that would be these trigger buttons right here, the rally group and the rally army, which is left and right mouse button. Basically, what I've been thinking about, or what I thought of for the burrow, and then I decided works better on these guys. So first off, the other thing that works good on these guys is this guy, right? Back to this guy, left click, right click. That would make sense for this guy, but I'm already using this guy for cycle, which it's more intuitive for cycle structures in my opinion. Just my opinion, but my opinion nonetheless. So since I don't want to print a second one of these, it's not necessarily that I don't want to print a second one of these. I think I just want more variety in the joystick. I want the joystick to be more interesting looking overall, so I don't want to duplicate this guy on it. There may be a point in time going forward where I have two of these because it makes sense having, for example, because this is left right, having up and down on another one, for example, as part of the controls, so you're kind of mixing up, down, left, right. I think that's a very interesting idea for a joystick, or for a control for a game, but that is not the case right now. So instead of this, though, what the idea I came up with, again, originally for the burrow, but I am going to do it for the left and right click instead, is sliders. So I'm going to basically have a pad, and I think I'm going to put them both on the same pad. They don't necessarily need to be, but the idea is, this is top down right now. This drawing is top down. It will have sliders. I'm just going to draw the boxes right now, but my intention is to put banners on them. Sliders, and then an extension spring pulling them back, or a rubber band. It's one of those things. I got a box full of rubber bands, so part of me kind of wanted to just throw a rubber band on it, but an extension spring or something. So you push the slider forward, it hits the micro switch, and then you release it, it comes back. That's the idea. And the reason I want to do it this way, and frankly, I may even stick this up on an angle, kind of like how we were talking about with the, with the Stream Deck. But the reason I'm putting it on an angle is because back to, I said putting flags on it. So rallying the army, rallying a group, you raise your banner up is the idea. So again, I'm going to put banners on here, little banner doodads, if you will. And you lift it up to rally, let it go, that stops the rally. And I think that's very A, intuitive, and B, thematic. So I really like this idea. And again, that's the other reason why I want to put this on an angle, have it more up and down so that the flags are actually going up and down instead of laying flat. And that is why I want to do this for that instead of Burrow. Now, the fact that I stole this idea from Burrow kind of makes me want to go back to the thrust, what do you call it? Holy cow, I said the word like 15 times, and now all of a sudden my brain's blanking on it. The throttle. It kind of makes me want to go back onto the throttle idea for Burrow. Set one of those up. But, yeah, I mean, I guess in a motorcycle or whatnot, the throttle does self-release and reset. So I guess that makes sense on that. The thing I was thinking about with throttle was actually more airplanes. I was thinking more airplanes when I was thinking about it originally. And, you know, on an airplane throttle, you set it up, or a boat or airplane throttle, you push it up and it holds position. So that's what I was thinking originally, which is why I discounted it. But I could change it to, instead of being a handled throttle, which is what I was thinking of originally, I could change it to actually, you know, a motorcycle type throttle, a handlebar throttle, which then would make more sense. So yeah, let's go with that one. So, all right, there we go. So we have our two ideas for the other controllers. So one last thing, we'll just hop back over here and run through it again. So WASD is the joystick. WASD joystick. Select structure is our left-right controller. Left-right controller, I didn't mention this, but back to camera. I didn't want to come back to camera, but whatever. We do have this set up for single input right now. This is easy enough to just, I normally use my X-Acto knife, but you know, whatever. Poke in here, put the pins down, and pull these pins out, and then split it into two buttons, or two pins, two JST connectors to go into two, you know, the Q and E, whatever those relate to on the, whoops, there we go. This was that one. So I just figure out what these inputs are right here on the joystick and just put those in the correct place. Put those buttons in the correct place. Which, honestly, looking at it, might be a little bit of a problem because I actually don't think the joystick, what do you call it? The USB joystick connector has a second analog input, so we might have to figure this out. One of those things, we can always remap it using a program, using, you know, what is it? Xbox CE or whatever it is. The remapping program. We can always do the remapping program to remap it to a keyboard button instead. So, yeah. That's those guys we were just talking about. Burrow, we were doing throttle for. Build and sell, again, are just going to be regular push buttons, regular 3-inch push buttons. And then the group rally army is going to be the flags. So, that is the rundown of how we are going to set up our new arcade prototype thingamabob. I say thingamabob because I always go and change what I'm calling it at any given point of time. And you get a blue screen right now because I don't have Fusion up. Fusion Desktop. There we go. All right. So anyway, sustain slide right here is just what I'm calling the push-ups for the banners for right now. And I went ahead and just created the file to get us started. One of those things, easy enough, just derived component base, which I always do. And that's where we're at. And I'm going to grab a quick sip of coffee because for the last 24 hours, I've been, for some reason, a bit stuffed up. Yeah, really couldn't tell you what exactly happened. It's one of those things, it's the middle of summer, and for some reason out of nowhere, my nose just started, not really even my nose, it's like the nose in the back of my throat just started getting stuffed up. So anyway, with that unneeded information out of the way, let's get to it. So, one of these things where I guess I'll just toss it at an arbitrary angle. I guess 60 degrees sounds alright. And it probably can be centered over top the center of this guy. So we'll draw it. One of those things I can't draw a line right now unless I do this guy. I know I hate this guy, but you know, this orientation. So, which means that we can come in here and just start here. So I'm thinking to draw the backboard first. And one of these things where I'm doing this instead of throwing a plane in here. Because basically the plane would have to go arbitrarily this far from. So basically, here, let me go ahead and throw the plane in here just to show you how intuitively I would think to do this. So since we don't have anything specifically to reference 60 degrees off of, like if this was an actual corner right here instead of a rounded corner, I would go ahead and actually, let's check something really quick. Okay, so I could, it's one of those things, so 0 degrees right here, in theory, is 45 degrees. So we could add another 30 degrees here. And this actually kind of would work, except for I wanted it centered over top this. So one way I'm thinking to, let me click from the other side. I could, okay, it's not going to switch directions on me anyway. This is 20 millimeters, right? So we could go back 10 millimeters, and that could be our plane. That's one way of doing this. If this was a sharp corner, which is what I was originally going to say, then I was going to do the same thing, but I was going to do plane at angle, take the sharp corner, and then offset it to 10 millimeters. That was my original plan. As is, although I should specify plane at angle, I would have done 60 degrees would have been my input on that instead of 30 degrees. Or actually 30 degrees isn't even right, is it? Because I can't do math on stream. So, as you guys are all aware, oh, actually, here's another thing. I didn't realize that Tangent had reference plane. So let me grab that off the origin then, and then I will get back to talking. There's the origin. And it's giving me an error for some reason. That is fascinating. Huh. So it doesn't like that plane. How about that plane? All right, there we go. So this actually does change it to 60 degrees in that case. I was going to say, anyway, we all understand what's going on here. So there's 60 degrees relative to the XY plane, which is what I wanted. I wanted 60 degrees relative to the XY plane. Otherwise, at the 45 degrees, that should have been 15 degrees. I think 45 plus 15 is 60. Yeah. Okay. So back to math on stream. Now, actually looking at the, we'll see what happens. We'll see what happens. Now, next problem is that, actually thinking about this more, again, this was not the way I was really going to do it. I was originally going to draw it from the side, so I didn't think through it completely because I just figured I had too much thinking. But actually, if we do this, we could start from, could we start from here? Start here, extrude that out. It's a little, I don't particularly like it, but we'll do it. Let's go ahead and do it for the lols. So, let us project that body. Yeah, and see, this is why I don't particularly like it, because I don't have a point of reference for, actually, never mind, I take it back. I can get a point of reference. Okay. So, let me, basically what happens is, with this plane at the angle here, I can't get intersections of it because it's tangent to this whole entire object. So it's never going to intersect this object, right? So let me just, for demonstrations purposes, intersect that. I get nothing. Well, I get the edge. It's tangent to the edge, so I get the edge. Okay, so I was technically wrong, but that's not what I wanted. I wanted to know where the center of this is and where the back side of this is for determining the size of this plate right here. That was my intention, because I don't want it overhanging too far, if any, past this plate. But I can actually go ahead and grab those by using planes, so that is what I will do, so that we continue to use that plane that I started with. Otherwise, what I was going to do, as I keep on coming back to it and cutting off halfway because I keep on coming up with new things to say, I was going to basically do this. Boom, 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 and boom, and then extrude that out, and we'd be done. But instead, we're doing it the long way, because the long way is, in a way, more correct, in another way, not really more correct. So here I've just drawn this plane right here. Our component, our base component, is centered on the origin. That is important because I'm going to come in here, and now I can do intersects on. Well, let me get that selection filter. Change the selection filter out to something. Actually, you know what? I guess I didn't need that plane, because I could do. Could I have done? Let's see something really quick. Okay. So, I was under the impression that I'd be able to select this plane as my intersect. And that is clearly not true. So, if I click that, though, as you can see, we don't get an intersect. Even if I zoom all the way out, it's not hiding somewhere, because that face does not extend through our plane, which is the problem here. The project thing, when you do projections, so let's just, for example, do that. As you can see, that's way down here. That is not accurate, because it's projecting across this line right here. It's going perpendicular to the plane to get the projection onto the plane. So that's why projection doesn't work, and why I'm trying to get the intersects. So what we can do instead, since this is all being difficult, let me really quick, just because I don't know. Obviously, this wants to do. See, it just says specified entities. I don't know what the list of specified entities is, but I'm going to check whether or not we can do the axis. So it actually looks like you can do axes, but not planes, it looks like. So we can do the axis here. And let me see what happens when we do that. So the funny thing is that that actually didn't come up, right? I don't have a dot. I was expecting a dot on the plane here, but that does not appear to be the case. So let's see. I'm trying to make this work just because we've done it this way at this point. And it was, again, the more difficult way to do it, the more roundabout way to do it, but I decided to do it anyway. Whoops, get out of here. So, the last thing I can think of off the top of my head on how to make this work is to do this. Finish sketch, create sketch on our new plane. Project that. I'm just going to use the body for right now, and then go way up here. And this is kind of really obnoxious, but it will work. Do this, and this would be the overall height, the maximum height at the back edge. So let's see if my extrusion is about yay tall. I'm feeling like maybe 75 millimeters to 100, 3 to 4 inches, somewhere in that range. Let's go 400, assuming that bigger is better. Or 4 inches. Yeah, 4 inches, 100, assuming that bigger is better. So I'll do that, and I'll toss this guy just at the bottom, just for reference. And I believe now, if I slide this guy back so that he's before this guy, intersect, that guy. So that is the height at which that guy intersects. So if we do that, yeah, as you can see, that should work. So looking from the side here, I can go ahead and hit the inspect button. Do that to that. I thought I clicked that, but oh, the inspect, what you call it, is short for some reason. Distance of 0. Very nice. All right. Close. Finish sketch. Let's inspect. Try that again. That point to that point. All right. So that says, interestingly, that says 33.54. Oh, I see why. I see why. Our angle is wrong. That is why. So, yeah, I'd have to do some math if I wanted this to full 4 inches. As you can see, this angle that I've got going on here does not hit our full 4 inches right here. So, we'd have to change that. And it's one of those things, this would be much easier done from the side, playing with this angle and whatnot, and making adjustments. So, we are going to hold down the Control-Z button, and at least you learned a little something there if you were not familiar with that way of going about this. But that way is not going to be doing us any favors today, so we're going to do this. Project that guy. Do that. Toss in this. I don't really want you doing that just yet, so do that. I could do an offset here, but I don't really like single wall offsets. I should say open loop offsets, because you got to connect up the sides, and that can be a little bit messy. The ends, connect up the ends to create a profile. So that is why I did not do that. And then I wanted to make sure this was actually, rather than parallel, collinear is what I wanted to make sure this was. And that can intersect that line. This guy can intersect down here. Whoops, that did not do what I expected it to do. Let's try that again. You click there. Cool. Good deal. Alright, and then obviously this is just wall distance. Okay, we don't have a wall distance yet. Or wall thickness, rather. Let's go ahead and do that. So the funny thing is that because we're going to kind of be leaning on this a good bit, I should either add extra supports if I don't trust it, or make the wall thickness a little bit thicker. I think I'll start with the supports instead. So we're going to start with our 3mm wall thickness. 3mm instead of the 2mm or the 1mm, because, again, I don't quite trust it, but at the same time, I don't think it's going to be that difficult. I'm going to go ahead and make these guys parallel. Actually, they're set to be parallel, so that's good. And trying to think. What do I need to do to make sure that this is... What's the relationship here? Well, I mean, it would be this angle being the same, right? But I don't really want to set the angle, so I guess I'll just come down here and set wall thickness. This is what I was trying to avoid doing, putting wall thickness down here too, but I'd rather not set a whole bunch of angles. So let's go back to 60. So that's 60 where we're at. And as we can see, if I do this guy, that is, interestingly, that is 50.67. Very interesting. I'm assuming that's 6.7. Yeah, 6.7. I'm actually a little bit confused why that is not 33. Alright, whichever. So 60, actually what I should do, rather, if I'm specific about the height that I want between these guys, what I should be doing is doing this instead. and this will set my angle. So as we saw, oh, actually that won't set my angle because this guy needs to quinky dink with that line right there. Alright, there we go. Now that sets my angle. So this is the overhang that we've got right now, the angle that we got right now. That's not terrible, honestly, the more I think about it. Back to our flags are going more or less straight up at this point, and the closer they get to going straight up, I just don't want them going completely straight up because it's harder to push. It's harder to push them straight up naturally when you're playing. You kind of got to honestly do an underhand thing. It'd actually be easier to come underneath and push upwards with your palm upwards, pointing up. So I don't think that's a good idea to have it too steep, but this, let's see. I'm just kind of visualizing it in my head. So the way I'm visualizing it in my head / at my desk is assuming that I've got the height here about correct for the top of it. I've actually got to come quite low below my desk. Like I actually go, all right. Yeah, actually that's not something I can't really show on stream based on my camera angle. So let us attempt to set something up here to demonstrate. Pretend this is my desk, okay? To get this angle, my fingers got to start way down here. So assume this is 20 millimeters right here. So this is the bottom of the extrusion right here. And to start pushing from the bottom of the extrusion up 3 inches, you see just how far below my desk line, this corner being my desk line, the top of my desk, I've got to be in order to push that up. Now there's 2 ways to solve that. One is to have some dead space, like round about here, and actually start pushing up here. So it goes from being 4 inches above the desk line, so from here to here. Try to get a sideways view so you have a better perspective. So it goes from being about yay tall to being, I'll turn it on the side now, yay tall, right? It more or less doubles in length and ends up being closer to the size of this paper right here. So 4 to 8 inches, actually 8 inches would be this end, right? So there you go. It would be the width of this piece of paper right here is what we would end up with, and only half of it would have the controls on it, because the bottom half is what we're reaching past in order to get not have to put our hand below, in order to not have our hand all the way down here when we start pushing, because it stops right here. In order to shift those controls up so that we can start right here, it has to be this full length of paper. So that's a bit of a problem. Now let us consider I'm just thinking, actually, let me grab something more like 4 inches, which would be this box over here. Yeah, it's about 4 inches. Okay, so here's the box over here. This right here, I'm not going to show you the front side because that will spoil things. Actually, it doesn't really spoil things unless you already know what it is. But regardless, no sense putting the front on the thing. I had a bad idea. I had an idea, which is bad because it's going to set back the Stream Deck a little bit as I play with the idea, which is what this box is from. Anyway, tangent out of the way. This is about our 4 inches, right? And we kind of want to not be below the desk, which means that we kind of actually want more of an angle like this. So whereas I was going more like this because I wanted the flags going up, one of 2 things have to happen at this point. Either one, we got to switch to a thumb method. So that is not a terrible idea. So I could just expect to, whenever I hit these buttons, use my thumb instead. That way I'm not reaching all the way down here. So that's one. In theory, I could also use my finger. Go like this, although that's a bit more difficult, obviously. Again, I'm assuming that my joystick is on my right hand and my left hand is for all other controls at this point. technically speaking, let's say this guy, not technically speaking. I do want this on my left hand because I should be moving my character at the same time I'm raising banners. At the same time I'm ordering my army around, I should be moving my character. So yeah, this should be on my left hand. I was going to say technically it could be in the middle and I could, reach over with my right hand, but not a good idea. So anyway, point being, yeah, if we need it more like this, so that we have so that we're coming at it a bit shallower. Do I hate that as much? So I guess the argument here is I had the banners going in line with this box like this, but I could always attach the banners this way, and then the banner goes upwards like this up the ramp. I guess that's the other possibility here, and therefore it's still getting raised. So that's an idea. So we could have it this big, a little bit less of an angle so that you can still use your fingertips to push them. Okay, but the banner is going this way instead to compensate. Not a terrible idea. Not a terrible idea. Any other ideas we can come up with? So I guess the other idea is, let's see, if I want it like this, if this is the angle I really want it at, that way the banner goes up more. I wonder, I'm kind of thinking maybe off at an angle instead, but I probably don't like that as much as the just changing it so the banner is going straight up and just lowering the angle. Yeah, alright. So the other benefit of lowering the angle is that it is easier to hit. When it's down like this, when it's like this, and even if we have the full sheet of paper height right here, it's still a little awkward to come up and in and to hit it up. It is still a little bit awkward, even if the controls are only on the top half of the paper right here. So lowering the angle does make it a lot more intuitive to just bang it really quick. So yeah, I think that's what we're going to do. We're just going to give up on it being this angle and lower the angle, and then have the flags coming up perpendicular. Not really perpendicular to this angle, perpendicular to the floor. Standing straight up in a layman's terms. Alright, so that being the case, we can go back to setting this angle. And I'm doing this with my right hand because I got my coffee in the left. So this angle now, we'll go back to, let's see what 30 looks like, just to, for argument's sake. So that's what 30 looks like. I mean, honestly, 30 is not terrible. I mean, it's not flat, at any rate. Let's try 30. I don't mind trying 30. Now, this intersect right here, I gotta figure out where, I mean, it should be on there. Should be one of those. Okay, it is that one. This has to go away now, and now this will overhang the extrusion by a good bit in order to get enough movement on the slide. The next thing is that right now I have this quinkydink with this, which may not be a good idea. Let's see. This guy, that guy. Okay, it is this guy. We may want to bring this up a bit because we're going to be putting either a spring or a rubber band in here, so we want some room for that. So, let's see. I'm thinking we might want maybe 4 to 5 millimeters. Let's say 5 millimeters, and we'll see how that turns out. So we got 5 millimeters there, and now the only other thing we are interested in is how far we want to push this. So let's assume that the slide starts out. I'm going to just throw a point in here for reference and dimension that out. So if the slide starts out, let's start it out, let's say 5 millimeters from the bottom. All right. And actually, you know what? I can just fully dimension this. So we can... All right. So this is the bad way of doing it right now, what I'm doing. We'll fix it in just a second, but just for demonstration purposes. So if we give ourselves a 5 millimeter in the middle, then we can sit here and say, okay, what feels like a good amount of movement? And one of these interesting things where, on the one hand, I'm recalling the the bidirectional controller that we made. Come on, where are we at? There we are. So I'm recalling this guy, and you will recall, so this is where my whatchamacallits are right now. I'm blanking on the name that I should be using them for them, but the things that hit the micro switches. For some reason, I am just totally blanking on what I'm supposed to be calling those, but the trippers for the micro switches are only at this much of an angle, only at that much of a movement. And I came to that conclusion after having them like way out here and doing a full 90 degrees. I realized that you really don't want that much movement. So I'm recalling this where I had to scale the amount of movement before you trip the micro switch. I had to scale that way back. And I kind of want to make this movement here on this edge smaller than I expect it to be, but at the same time we are doing a different type of mechanism here, and therefore I think the change in I was gonna say I think the change in functionality, the change in user experience merits a change in distance. So I think it's more understandable that from a user's perspective that it's moving a certain amount as opposed to being a very quick activation. One of those things. In game, frankly, it may be a bit obnoxious to have to move it so far while I'm controlling an army, but frankly, again, the whole entire point of doing all these designs for the custom prototype, arcade prototype, controller prototype, rig prototype, the point of doing all these design things is specifically user experience, right? It's not necessarily, I mean, even user experience is a bad term for it because UX generally tries to make things easier for the user. So I'm not even using really the correct term, but it's very much a creative process, a creative experience, a creative gameplay experience is what I'm building here. Or implementing. I don't know if building's the correct word either, because let's face it, I'm not the one who's making the game. I'm just creating inputs here. But point being is that I was tempted to bring this down to something like 25 millimeters, but I think I will go ahead and put it at like 50. And now, way back like 5 minutes ago, I said I was doing this wrong. So we are going to go ahead and delete these guys. And one of those things, we'll just have 50 millimeter. Actually, we will just come in here first, rather, is what I should be doing. Slide length 50 millimeters is what I wanted there, and then do slide length plus 5 plus 5, which is my reminder that 5 millimeters is what I'm giving at the top and bottom for space. And this is now completely constrained. The next question is, do I put these supporting walls in now? Which I kind of think I do. So let's go ahead and draw those in. This will be, rather than horizontal, I do want this perpendicular instead, defined as perpendicular instead. And then we can have this collinear with that guy and bring you up, toss another guy in here, that guy grabs onto there, grabs onto there, and then it's collinear with there. And by Growzon, I obviously mean Coinkidinked. Alright, cool. So I'm going to extrude this top part first and then come back and extrude walls as ribs. So they're not going to run the full length of it because obviously that would get in our way. I'm just going to do walls here and there. Now looking at this, okay, I am centered on the origin, which means that obviously my while we're centered on the origin with the base component, clearly the base component is not centered on the origin in the x-axis, which is a bit of a whoops. But one of those things, again, the extrusion, I always extend anyway, so it doesn't matter that much. So we are extruding that. Symmetric, whole distance, and the question is, next, let's see, if I've got, let's make the buttons a full inch wide, so that's 25 millimeters. Then we want some space between it. We don't want, we don't need rather too much space. I guess we could go ahead and call it something like, so I'm debating between 5 and 10 millimeters right now is what I'm debating between. I think I'm going to give us a little bit more space and go with the 10 millimeters. So that, and then we can do 5 millimeters on the edge. Well, yeah, 5 millimeters on the edge is fine. Yeah, I'm okay with that. Okay. The next thing that I kind of was thinking right there that I stopped myself on is instead of, yeah, all right. I am getting ideas now, and this wasn't my initial intention, but actually, hold the phone. We should bring the micro switch in before we do this, because we actually need to make sure we leave ourselves enough space to plug the micro switch in. So I'm going to finish sketch here, and let's grab the micro switch. There's our micro switch that we have. Insert into current design. Yeah, and you see how big the micro switch is, which is what I was a bit concerned about. So we're going to just spin him around real quick. And I'm just going to throw him off this way for the time being. Now, one of the things, I've said this before, obviously this tab is way longer than we need it to be. It wasn't a big deal on the controller, on the joystick, because we were offsetting the micro switches anyway from the, offsetting them from the center shaft. So they were already, it just changed where we're mounting the holes. This is all I'm trying to get at. The mounting holes just changed a little bit, so it wasn't that big of a deal. This guy, it is kind of a big deal because we have a limited amount of space here. So I haven't tried it yet, as I was getting to saying, but I'm going to have to try to cut this down. I think I've got to decide the best way to go about that. I don't particularly want to throw it on the abrasive saw at work. Big 18-inch abrasive saw, and probably not a good idea. I do not have a vertical bandsaw, which would, A, be a little bit overkill, but B, also be dangerous, and C, I don't have. So it's a moot point. So at that point, I've got to figure out whether or not my shears probably aren't going to leave a good enough edge. I don't know. I cut some pretty heavy wire with my wire cutters. I say shears, but they're wire cutters. Wire cutters cut pretty heavy wire, so they might be able to get through this. Otherwise, if I cut them with a Dremel cutoff blade, that's going to leave them a bit burred, and then I'm going to have to deburr it. I don't know. I'm going to have to figure that one out. First thing I'm going to do is not edit this in place because we can't, which is annoying. Can I just do this? Distance to object, that cut, yeah, can't cut because we can't edit in place. Okay, can't edit in place, so I guess we're just gonna have to ignore this tab for right now. because I don't have any other options. So, space we need between micro switches, because the micro switches should all be meh. Actually, why am I don't need to place the micro switch in this orientation, do I? Okay. No, I don't. Good thinking me. All right, we're going to turn the micro switches sideways, and then let me do this just so that I can get back to the placement. We are going to do this 180, and then put them like this. Yeah, that is an idea, me. Good idea, me. All right, micro switch is going like this, and that's definitely less than an inch. I forget what it is, but it's definitely less than an inch. All right, about 10 millimeters, 9.5. So yeah, that gives us all of that. The only problem then at that point is I just realized that that's a bit tall. Components. Click that guy. So this guy, even if we cut the down, this thing, the flap. Actually, I wonder if I can get the micro switch apart and take the flap out completely, because I don't need it. And furthermore, we can place it like that, actually. Yeah, if we place it like that, okay, then I was a little concerned about these terminals running into the ground. But if we mount it at an angle like this, that solves that problem, plus the doohickey that is supposed to be the actuator that's going to be hitting the button is hitting it straight on instead of hitting it at an angle. So okay, cool. All right, that solves all my problems. So let us get back to work then. In that case, we do not have to design around that. We will be able to fit it in after we get it designed the way we want to. Now, the one thing that I stopped myself from saying, backtracking way 5 minutes ago, is that it occurred to me that if I'm going to put 5 millimeters on the edge, on the outside edges, and we've got 10 millimeters between the push switches, then that definitely sounds like there are 5 millimeters dead center. So in other words, 10 millimeters is half of 5 millimeters, which means that if I array this out and only do one lines and then attach them together, we get 2 lines, right? So we can actually just create a single switch one and then pattern it out. Well, I'm not even going to pattern it out here. I'm going to go ahead and just print it out and then stick them next to each other is the idea. So these, instead of being one unit, will be single units, just single push flags. And that will simplify the design, and it will allow me in the future to just print single ones if I want to go up to 3 or 4 or 5 or 6, you know. And yeah, that is what we're going to do at this point. So let's go ahead and get to it. That does simplify our design. So I am very happy that I've made the decision. Back to symmetric overall. Actually, come back up here. Button width, let's define that. Button width. Button width. All right, fine. I won't actually. 25. And then I'm not going to bother putting the 5 millimeter spacing in there. You can just assume that. Button width plus 5 plus 5. Symmetric, both sides. And new component. There we go. And this will be frame. And then, do I do this now or do I do this later? Do I put the walls in now or later? I think I put the walls in later, honestly. So let us come into frame and start doing the slide then. And I'm tempted to... Where did we put that? Huh. Oh, that's right. I did it from the side. I was gonna say, where did we put the plane? But obviously, the plane does not exist anymore because it was just plain easier to do from the side. So we come back in here. Now I will be coming from the top. And I actually don't want the body. I want just this face. And toss a little slot in here. So the way I'm thinking of putting the slide switch together is we'll probably screw it in from the bottom. I'm thinking, do we screw it in from the bottom? Do we screw it in from the top? I was only going to do the bottom because a nut takes up less space than the knurled tops. I prefer using the knurled tops on the smaller the smaller bolts, only because on the smaller bolts the hex can strip out. Wow. Okay, brain working, functioning. Okay. The hex can strip out on the smaller bolts, which is why I tend towards the knurl knob on the top, because the knurl knob is a larger size hex inset. The only question though is, are buttons 25 millimeters wide? So we can go with, for example, an M6 or an M5 or something like that, holding it together. And in that case, the button top is I'm more than happy to use a button top on it, because the hex inset is much larger and less likely to strip out. Interesting. Design question. Okay, here is the alternative. The alternative is... actually, no, that's not a good alternative. I take it back. I was going to say the alternative is that we could, with a nut, using a nut instead, we can capture that nut through the side of the button. Therefore, you don't see it on the top of the button. I decided that is not a good argument right now, because I plan on putting quote-unquote keycaps on this anyway. Back to this flag is what I'm adding on to this. So if we're going to be mounting stuff on top of that, that will cover up the screw head anyway, the bolt head anyway. So it's not actually a good argument. Alright, yeah, I think we will capture the nut on the bottom of it and then bolt it down from the top. Just makes life easier instead of having to take this whole thing off. So if we wanted to change that, if we decide we need to change the slider out on this thing instead of just changing the keycap, in that case, in order to get it unbolted, we'd have to unbolt the front of this, take it off, flip it upside down to access the bolt to unbolt it. I mean, unless we really want to struggle, which I don't. So, that being the case, we will go with option A, which is bolting it from the top. Now, back to what size bolt. The size bolt I'm thinking is, actually, let me Control-Z that, just because, again, I'm always paranoid that I'm going to accidentally grab a body reference instead of this projection line, because I don't trust Fusion. And I normally go corner to corner. I was thinking maybe I shouldn't this time, but I have come to the conclusion that I don't have any good reasons not to. So, the bolt size, as I keep on saying and keep on getting distracted on, we can say that's an M5. Let's just call it an M5 right now. So, I'm going to go ahead and just drop in an M5 right now. 5. And then we want at least 3 millimeters of meat around it, and that actually gets us pretty close. So I was just eyeballing this up relative to the face, right? And if I make this, let's make this centered on that is what I want. And then this is just for reference. We can tangent that to that, and we can check on that. And so the slidey bit that goes in the middle here is going to be 11 millimeters. 11 millimeters being just under half an inch compared to an 1-inch button sounds perfectly fine to me. It sounds like we got a 1/4 inch in each side. That's actually a little large, frankly speaking. We could go smaller relative to the button size, but I think we'll go ahead and leave it for right now. Meanwhile, the distance from here to here is obviously 5 millimeters as we mapped out before. And we can go ahead and just extrude this all. Distance all flippity floppity. And there we go. So that is the slot for the slider, and now we can go ahead and make the slider, and I will make the slider and not the keycap at this point. We'll go ahead and make keycaps separately. So new component, slider, and we will start with the body, and then we will decide how we're going to attach it down here, because I'm not entirely sure myself. Back to, I said an extension spring made sense. The only thing that I'm realizing at this moment is that if you look here, this space is either the rubber band or the extension spring when it is completely at rest. However, it needs to still have, it needs to be pre-stretched basically to make sure it has tension against the bottom here. So it's snapping towards the bottom still. It still has force being exerted against the bottom. So, that is not a lot of space is what I'm trying to say here, is what I'm getting at. That is not a lot of space to be pulling it back, which may mean that we want a second part to this. So, for example, we may want to have it looped from here around a rod of some kind, 3D printed or whatnot, and then pre-tensioned going this way. That is an option for how to solve this, and that may be what we go with, just to make our life easier. Because again, otherwise, with only 5 millimeter space between here and the wall, plus you need an attachment point, that does not give you very much room to pre-tension this and still have enough pull to get your full 2 inches. So we very well may need to come back this way. So the question is, do I want to do the slider right now, or do I want to get that sorted right now? I guess I may as well get that sorted right now. Let's see, the frame looks like at this point, it is going to be printed like this, is how it wants to be printed. Well, not quite like that. One of these things, this is going to be a little difficult to line up, but imagine that this face is flat against the ground. That is the most ideal way to have this printed, because we want this face, which you're going to be staring at, to be the cleanest. Alternatively, we could print it on the side. That would be the next best way. So like this. Let me flip over to the other way so that you can see the back. So printed like this. And that is option number 2, and that's not terrible. The only problem, obviously, is that we probably, because the slider is so important that the slider moves free, we're probably going to want to put support in there. Yeah, you know what? We can print it in this orientation, I guess. So that means that the rod that we put through here, we probably want to make it a bolt, because our layer lines are going to be running across like this. And since our layer lines are going to be running across like that, it's going to make that section, if we throw a rod in the middle here, it will make that rod section weakest. So we may just want to put a bolt in there, as I was saying, instead. The other nice thing about putting a bolt in there is that we can put the bolt in after we have the rubber band attached. So we can attach the rubber band here on the slider and then back here, and then just push the rubber band forward and slide the bolt in behind it. Is a good idea, I think. Yeah, I think that's a good idea. Okay, let's go ahead and do that then. So, the next question is this slider. Obviously, it's going to stick out the bottom here a bit. Let me close this guy. I always leave the data bar open. I try to close it, but forget. The slider is going to stick out a bit right here, and therefore we actually kind of want the bolt out as well because we want the slider to be pulling parallel. So if the bolt is too close, that means, let me go ahead and draw really quick. So imagine the slider sticks out like this on the back side. Rough lines, okay? And it's attached. Circle, please. There we go. So it attaches right here, let's say. Let's say the circle is attachment point. We want this line right here, which is our rubber band, to be parallel to this wall, which means that at the point that it comes back this way to attach back here, this is where the bolt wants to be. We want the bolt to be right in this little pocket right here. If we have this pocket, and actually that connected there, so that's going to make my life a little bit difficult. If we move the bolt up, stop snapping. There we go. If we move the bolt up here, then you can see how this all of a sudden causes that line to be off. It's not running parallel with the slide, which means that it's torquing on the slide. It's skewing the slide. I'm blanking again on the word that I want to use because that's one of those kinds of nights. It's canting the slide, I guess, is what I was looking for. And we don't want that. So we want to actually, I know I keep on changing my mind here, but we probably do want to design the slide first before we design the bolt, or before we place the bolt at any rate. The fact of the matter is that the bolt can be placed, we could do the back section right here, the back holder for the rubber band, spring, whatever, back here. And it's one of those things. At this point, now that we're going around this curve, it does make more sense to use a rubber band, but then an extension spring. But the fact of the matter is that the alternative actually is to have an extension spring attached here and then to a rope. And the rope basically goes around a pulley that goes to the slide. So the slide pulls the rope, and then the rope extends the extension spring. That's the other way to do it. But one of those things simplifying the design, and I have a box full of rubber bands burning a hole in my pocket. I guess we'll just be using a rubber band. So let us get back to this slider then. And what orientation is the best way to build this slider is a good question. I honestly think it may just be from that plane we were using before. So this plane was front of frame. Yeah, front of frame. And we will go ahead and just project this out. Projected. And we are one of those things, we want it running square with the sides here. We don't really want it to be a round slide. It can be. Don't get me wrong. It can be. But I feel more comfortable, let's say, with it being square and nested completely in there. So that is how I'm going to design it. Because, again, that makes me more comfortable. So there's that. And then I will go ahead and make it completely square. So that side equal to that side. And then we can go ahead and extrude this out. This will obviously be the center point. And we do want this sticking out. It's 2 dimensions here. We do want it sticking out slightly above the face. We don't want any key keycaps to be touching the face. So we're going to do 2 things. One, we're going to have the front side sticking out a little bit, giving ourselves a little bit of clearance. And then whatever we attach the keycap to, we'll make that feature. We'll create that feature. And then that feature will also be, and it looks like we are going backwards. Okay, there we go. Up there. That feature will also be extended out far enough for the keycap to not interfere. There we go. And that was clearly not the correct face. Alright, cool. Meanwhile, the backside can actually be tight. All right, so this is a good. Do I want to change? So, There's a couple ways of doing this. I was thinking I was going to extend. So, yeah, think before you talk. So I was thinking whatever I put on top of here would keep it down, but then I just remembered that it's keycap and therefore it's not going to keep it down. So I do have to put wings on the front side here and then wings on the back side so that it sandwiches the plate. The alternative to that is actually a bit interesting, and I'm tempted to do it. And that is to make this basically dovetail shaped, because the dovetail will pull into and keep it from not really pull into isn't exactly the correct term. It will sit in the trough basically right there and not want to come out to begin with, because we're going to be pushing in this orientation. So if this is the wider part right here, then it wants to fall down into the trough, which means that it's not going to come this way naturally, and we can still go ahead and throw a little bit of back wings in here to keep it from going that way if it wants to. So it removes the front wings and still adds the back wings, point being. It is definitely an idea. We do have to go back and change what we did before, though, which is not that big of a deal. So, yeah, okay. We're going to back up. I do like that idea better. So, we'll come back here and actually delete this altogether. And that will obviously cause a rather back of frame. And yeah, I'm just gonna call it back of frame. So technically I should call it like back of top of frame or something like that, but that's what I was going to say is that's going to cause an error down here on this sketch because we projected out that hole. Obviously I'm just going to live with that, and I'm going to project out the sketch instead, because all I really want to do is offset this. Alright, doink, 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 and doink. And I should have turned the other one off before I did that, just because, again, I always get paranoid that Fusion is going to select something that I did not intend. And as I was saying, the backside is going to be the skinnier size. The only question is how much skinnier do we want it to be? And I guess 1.5 is fine for right now. We'll see how that actually turns out. This is going to be construction lines around here, because we don't actually want to loft to those guys. And the last thing we have to do is actually come in here to this guy and make this guy a bit bigger to compensate for the fact that we're making it smaller on the backside. Because as you can see, this circle right here, if I can't turn the sketch on right now, so let me come back here, turn this sketch on. So you see how this is the cutout on the bottom side right here, these lines right here, and they overlap with our circle right there, which means that we have less meat, in theory 1.5 millimeter meat, going around the on the sides here, padding out, you know, providing support for the bolt, which was not what we wanted. Now, to be fair, I said 3 millimeters right here, but for padding around bolt, I've been doing 2 millimeters more often. What I should do, however, so there was a couple ways to fix this problem. What I will do instead is have this and have this be 1.5, which is the offset for that I just showed you, right? That was the offset on the bottom layer on the back side, and then we can just tangent to that, and that is the way we can fix it. And as you can see, let me go to top here. Yeah, there we go. Top, you can see it. So as you can see, the bottom layer here, the backside, the sketch we have on the backside, now lines up with that wall that we put in there as a space around the bolt. So now we go ahead and obviously just loft this out. Easy enough. loft and... Actually, you know what? I'm going to come back in here because obviously this is getting in my way and turn that into construction lines. Loft, loft, loft. Luft and luft. And turn bodies back on. That's a cut. That's good for me. And now we can come down here. And interestingly enough, it is not giving me an error, but as you can see, they're not connected. So it's not giving me an error, I guess, because it realized that this hole right here is the same hole. Now, obviously, if you've been following my other videos, we've not had that situation before. We've had it lose projections before, so I don't know. You can explain that one to me. Well, whatever. I guess because we projected the face, right? We projected the face, so this is not actually the same hole as far as the face is concerned. I suppose that is the explanation. And then it lost the constraints on here, but it just didn't raise an error because I couldn't tell you. So we'll go ahead and stop complaining and just get this guy lined back up. And one of these things where I think I am going to go ahead and just use our good old cut operation here. So frankly, I was thinking I was going to loft this out just like the other one, but designing the extra sketch is more or less just as time brain. Just as time. Good bunch of men. It requires just as much time to add the extra sketch to loft it down to as it does to hit the combine cut function. So I'm just going to do that. The last thing that distracted me is obviously these tops and bottoms are at angles, which I didn't think was a problem, but there's no reason for them to be. So actually, here is one question. So if I made that perpendicular, right, there'd be a different distance from the top and the bottom, which means that maybe we're better off like this. So let me go ahead and hit this really quick and inspect that. So that's 4.768. And up here should be 5. Yeah, so that's 5. So if I just cut this straight down without this loft right here, then it would be a lot closer to the bottom here. It doesn't necessarily matter. I'm going to do that just because it keeps everything cleaner in the top and bottom way. Otherwise, I got to also have to worry about the body here for the slider lining up well against here, which is just one more headache. I mean, not really a headache, but one more point of failure. So let's come back in here to sketch. And instead of offsetting this, I will go ahead and turn these lines on, and obviously that's very hard to see because the body's in the way. Turn those lines on, and then we will just do this instead and draw my 1.5 offsets here. 1.5, and then we're gonna have to fix the loft. So there's sketch number 1 and sketch number 2. So there's that. And now that when we look at the body, as you can see, that is perpendicular to the face, which makes life easier. As I said, it's just less to worry about. So back in here on the slider, we can go ahead and, as I was saying, as I keep on saying, but now I've got to reconstrain the sketch because I don't know why. We have the same loft as we had before, so whatever feature was created by the loft I would expect to be picked up by this guy, but I try not to complain. It's just they make it very hard. They make it very, very hard. Alright, back to this. 2, I wanted 1, I had 2 before, right? I had 2 at the top, and then distance to object. I'm just going to go flush with this because we're going to add the wings on the bottom. So That is fine. Again, we don't need weakness on the top now because it's not going to fall through. However, because I'm doing it this way, we do need combine that guy with that guy, cut, keep tools, etc. So now that is, dovetailed to match the other one. And now we can go ahead and on the slider, add a new component. Retainer, which is what I'm calling the wings. And go from the back of frame. Actually, no, I should go from the back of slider just in case I decide to extend the slider out past the, what sketch is on that one? Okay. Just in case I decide to extend this slider out to give myself more play. I'm expecting not to do that because I'm expecting to be able to just loosen the bolt up if it's too tight, is my intention here. So probably not going to come up, but point being, let me turn these guys really quick to construction lines because we don't need them. They're just for reference. I should center this guy though, center at least one of them at any rate, and then we can go for the overlap. Like 3mm is fine. It doesn't have to bite much. It's not holding much force. It's not doing much at any rate. And again, 3mm, just wall thickness. And I just realized the sketch is on the wrong plane, or on the wrong object rather, because I came up here to create that plane and forgot to hop back down. All right, there we go. Just a second to get that put back into place. Centered, collinear, and 3. And now we can go ahead and wall thickness, new body, and that is the back right there. And now actually we want to go ahead and throw our captured nut in there, so I will toss this plane in here. I'm gonna rename the planes after I get this done just because. There's that, and frankly the first sketch did not have much on it. I could have done it on the first sketch, but I didn't, so there. Turn the bodies off, get my center line, get my polygon. This shouldn't matter what orientation it is, so I'm just going to make it parallel to that. Get them centered up. And now I got to grab a M5 and figure out what it is because, again, M5 not one of the sizes I have memorized. M5. And I guess I'm getting kind of low on M5 bolts, so I might have to order some more. And I just dropped it. There it is. Alright, M5. M5. Let's see. 0. And we are looking at 8mm. Reading more like 7.95, but I'm going to round. And your thickness is 3.8. And I'm not going to bother doing anything with that because that's going to go all the way through. So our backplate actually needs to be bigger. So let us fix that. Oh, and it accidentally cut both of them. It's funny, I've been real good with making sure that we're not cutting multiple bodies recently. You know, coming in here to objects to cut and fixing that. But clearly did not right there. Failure. Alright, so this is going to end up being 5mm. That will give us a little over a millimeter 0.2-ish of space between the inside wall and there. Again, we're not cranking it down, plus it's getting cranked down directly onto more plastic. So frankly, even if it gets cranked down, it's not going to tear out the backside because it's just running into more plastic, like I said. So we don't actually have to worry about the wall being that thick. Frankly, I could just make it 3.8 and have it come all the way through. No, I can't really do that, only because then it wouldn't be tightening down the wings right here. We do want it pulling down the wings a bit, so I can't actually do what I just said. Let's turn this back on and let us actually come in here and set our bolt as well. So, trying to, hopefully that's constrained correctly. So there's our bolt, and I can go ahead and hit finish, and we will extrude this through both bodies this time. So turn that back on real quick, right quick. There, distance to object, and going all the way up top to here. That is our bolt. And come up to slider. We'll want to go ahead and put the bolt head in there now. And the bolt head is I said I was going to name my planes. I should probably do that. Just a minute, though. I will remember this number. 9.38-ish. I'll call it 9.4. Okay, 9.4. I will remember that. Otherwise, we come in here. This is bottom of slider. Slider. And this one is bottom of retainer. And now we can get a top of slider. Top of slider. Go ahead and project that out. Turn the other sketch off because we don't need it. There it is. Turn the bodies off for the time being because we don't need to see those either. Off and off. And I said 9.8, right? Oh boy. I said I was going to remember it. Goldfish, 9.4. 9.4 sounds right. I think I said 9.4 the first time. Not because the calipers are saying I said 9.4, but because I remember I said 9.4. Definitely, that's why. All right. Body. And we need to go, let us see, 2.55. Now, this is another situation where we're going 2.55 for this head. And I'm hoping I'm not getting too close to the frame. We may want to go ahead and raise this up a bit more. Yeah, you know what? I'm going to... well, you know what? Rather than just going by gut, let's go ahead and get our section analysis. We have tools. All right, so there's our section analysis. And we're looking at... Yeah, I mean, it's basically a distance from this wall to this wall, right? The corner does not actually get far enough down, it doesn't look like. Oh, actually. I would want instead to go this direction because I was worried more about the dovetails here. So let's do that. Come from this face and then back up. And let's look at it. Yeah. So this distance is what I was worried about here. And it does look like we're getting a little close, so let me go ahead and do this. And yeah, I can go ahead and take that. And it should have minimum distance. Okay, it has just a distance, and that is less than 1 millimeter, so that is close. So let us come back up here to this guy. And we will go 4 millimeters at the top. And now we are much further away. I mean, frankly, we're a good 1.5 in this direction, just in the, whatever direction you want to call this, Z-ish direction, because it's not directly directly perpendicular to Z at this point, but that is plenty. So, what else? The last thing we need to do. So the bolt is getting in the way at this point. The bolt head especially is getting in the way of doing any specific features for this keycap. So I'm thinking the keycap is just going to have to sit on top of there, frankly. I was hoping to do some kind of feature for the keycap, some kind of smaller feature, I should say, for the keycap. But it looks like the outside wall of the keycap is just going to have to be this whole entire thing. I'll turn the section analysis off. So the keycap is going to have to just stick directly on these four walls right here. I was hoping to stick something on top. I was hoping this was going to be a bit smaller, and then we could put a outline to it, basically. I was thinking about just doing another circle up here, you know, and just having that as the rim, it being a bit smaller than what we have exposed right here. But I just plain do not have enough meat up here to make a difference. So at this point, the keycap is just going to have to sit on this square part right here. Anything else we need then in that case? I guess just offsetting some faces here to make sure that we have our tolerances for 3D printing. And I'm going to grab the bottom faces first because I'm concerned that I click this and for some reason it comes up with fillet for some reason. So, new offsets. And again, 0.05 is what I use for 3D printing offsets. 5, that is ... There we go. And that is that. So now we need to add the feature to attach to for the rubber band. So let's come back up to frame. Let's think about this. So at this point, with how big this is, how far out it's sticking, I should say, I was hoping to put it off on this side, but I don't know that that's reasonable at this point. Here's our base component. Yeah, as you can see, that's a bit... It's not much space now, is it? Yeah, my original intention was putting something down here and then coming this way with it. But I guess we're just better off putting the bolt down here. And it's one of those things, so long as we have enough space. Now, obviously, I normally try to keep all my bolts the same size. That is not applying to this situation. We could... let's see. So first off, this slider is dictated in size largely by the fact that we're using M5s. I could drop it down to M3s if I planned on having the bolt down here being M3, which is what my plan is. My plan is just to toss an M3 down here as our little pulley, quote-unquote pulley. And honestly, the pulley probably should have an actual pulley on it, so the shaft should have an actual pulley on it, is what probably should happen here. I'm trying to think. Half of me wonders whether or not I shouldn't actually put a whole entire rim around here and wrap the rubber band around here. I'm a little concerned about the stretch around there, just causing extra pull on it. But it frankly, my bigger concern, the reason I'm bringing that up, is because I'm a bit concerned because of how little space we have here, that any feature I put on the bottom here to hold the rubber band actually ends up snapping off. Now the alternative which just occurred to me is I could scoop out these wings. I could carve out in here, drop this back a little bit more, We may have to lift this whole entire thing up. But I'm thinking if I expose the bolt instead, put the rubber band on the bolt itself instead, then I don't have to worry about the bolt snapping, obviously. Now, I'm going quiet because I'm thinking here. It just occurred to me that with the rubber band down here, the rubber band now, I mean, and it's not now, it's always has wanted to actually tilt this backwards. So it's going to be pulling down like this, which is going to want to pull the whole entire thing, cantilever the whole entire thing around backwards like this, which is something I totally missed at the beginning. I should have seen that one coming. So the way that would be fixed is we put the bolt through here, dead center here, and have the rubber band run in line with the slot. Let's see. This wants to cantilever back here. Our problem is that... So honestly, I wonder if the dovetails are actually doing enough. I was thinking it was just going to roll over the backside of the dovetail is what I was thinking. But maybe the dovetail is holding it enough. Maybe we'd actually just run with this for right now. Maybe that's what I'm going to do. I'm going to run with this for right now and see whether or not it actually causes a problem. I'm feeling like this whole entire thing right here is going to just tip because of the force getting pulled down right here. If I change the force to be pulling down the center, like I was saying, then we shouldn't have that problem. So that is in a solution going forward if we need it. But for the time being, I may want to just try this out as is, and then if it works, it works. Yeah, no. One thing I just realized is I said our slide distance is 2 millimeters. That is technically incorrect. It's 2 millimeters minus the width of this. So if we want to fix that, technically speaking, what we should do is come in here. Actually, no, back in here. Yeah, it should be back in here. Nope, all the way up top. I gotta come all the way up top. Our first sketch right here. So it would be slide length plus slot width. So we gotta come actually back here and double check how we defined our slot width. So slot width is dovetail times 2 plus wall bolt wall thickness times 2 plus bolt size, if we want to go that route. Otherwise, it's one of those things. 5 plus 2 times 2 is 4 is 9 plus 1.5 times 2 is 3 is 12 millimeters. So it's 50 minus 12 millimeters right now is our slide distance. So if you can tell the difference between 2 inches and 1.5 inches would be the only argument. So instead of sliding 2 inches, we're sliding 1.5 inches, and is anybody going to really miss that 1.5 inches is the real question. Is anybody going to be able to tell the difference between the two? I'm kind of just trying it myself. And honestly, I kind of can. Basically, the way I measure a lot of stuff is each segment on my index finger is about 1 inch, right? So I'm basically going to the middle of my second knuckle, or like between the second and first knuckle, right? I'm checking that distance, and then I'm sliding all the way to the second knuckle, just against my desk. And I kind of can tell the difference. It kind of does make a difference whether or not I'm going halfway or all the way. However, that's only, I guess, because I'm getting the sensation of hitting the inside of my knuckle, right? So here, screw it. Here's the camera. So on the edge of my desk, I was just basically going like this, right? I was starting here and sliding to here. Let me get you a side view so you can see where I'm stopping. So I'm starting here, and let me use a side that is not going to catch my finger. So starting here, going to here, and then starting here and coming all the way 2 inches, right? Approximately 2 inches. And again, I think that may just be the sensation of feeling against the bottom side of my knuckle right here as opposed to here. It may just be that sensation, so it may not actually be anything serious, but yeah, I probably just overthinking it, probably overcomplicating it. So Control Z. At this point, I think I do throw the ridge on this guy for the rubber band to hold the rubber band. Let me check the rubber band real quick. Rubber band thickness is, somehow we ended up on inches. Back to millimeters. 6.3 millimeters. 6.3 millimeters is really thick. I don't want to make this 6.3 millimeters, do I? Well, it's 6.3 millimeters plus the ridge. This is already at 5. Ick. Okay. Let us consider. All right. Yeah. This is difficult. Okay. This would not be as much of a problem if I was not trying to wrap it around. If it was just coming from the end, then it's one of those things that could just hook on, and if it was folded up, it wouldn't really matter. But because it's going around the edge, I don't particularly want to have it folded up around the edge, scrunched up around the edge. I want it laying flat against the edge is my issue here. Conundrum. It's funny, we went and simplified the design down to 1, and now all of a sudden we're having issues. Issues that we'd still have doing it the other way, but, oh boy. And it just occurred to me that we haven't even put in the micro switch yet. Nice. We need to add that on. Alternative solution is, so actually we have a little bit of an no, never mind. I still need the pre-stretch. I was going to say, it just occurred to me that rather than the rubber band coming around this way and then coming this way, in theory we could TP it over top of this and then pin it on the sides here. But it doesn't have enough pre-stretch probably, unless I wanted to do something to add that pre-stretch. For example, pinch it in place at the bottom to have it pre-stretched instead of running it backwards this way. It's not a bad idea. Honestly, it's not a bad idea. We still have the issue though of the 6.2 millimeter. I said 6.2, right? I might have said 6.3. Actually, this might just be 6 and I might be mismeasuring. Let's see what the box says. What does the box say? Box. Size 64. Size 64. Quarter inch 6 millimeters. Okay. So box says it's supposed to be a flat 6 millimeters. But frankly, as I was getting to, it may not actually be a bad idea to simplify this. And now what I'm thinking is pinch it down here between the extrusion and the wall, between the extrusion and the wall, in order to tension it. Not a bad idea, I don't think. The only question is how much. Yeah, that's more than. Yeah, we can get more than 2 inches of stretch even if I pre-stretch it. I was just a little concerned that I might be getting too much here, but that looks like that's more than 2 inches of stretch after I pre-stretch it, pre-tension it. So now I'm thinking that even if I do go down in between the extrusion and the wall here, that's my angle isn't good. I still need a bolt to keep my angle good. And if I have my bolt to keep my angle good, then it's one of those deals where at that point, you may as well, instead of running all the way back, put a T-nut in here and fasten it down right here with a T-nut to tension it, and then still have your bolt in here to keep it that way. So we're more or less back to square one with no problem solved. And at that point, I think that the most reasonable thing to do is to come down here, go up to 10 millimeters, and use the space. So slider now is going to end up being, let's call it 6.3. I'll trust it to hold up. That trust may be ill-founded, but I'll trust it to hold up. So, actually retainer, sorry. I meant retainer. So 6.3. So this is going to give me 3 millimeters of wall on the backside past the rubber band, because the rubber band, again, nominally is 6 millimeters. So let me go ahead and add that wall in. I should have a back. Yep, I have that plane right there. So I can use that plane right there. Let's grab it and project this out. And actually, I kind of want to project it out before we add the extra features in, making my life miserable. And by making my life miserable, I mean just adding complexity to the design, to the drawing space rather, is what I should say. Let's leave them in. So again, these are just to retain the rubber band to keep it from sliding off the backside right now. So there is, try that again. There we go. And as for thickness, it's one of those things, the rubber band is very thin, so we don't need that much thickness. So I guess I'll just call it like 2 millimeters. And we'll go ahead and extrude that up. -3 is what we just gave us. So in theory, there should be 6 millimeters between here and here. Between that face and... Try again. That face. Yep. No, that says... Oh, I know what I did. I was an idiot. I said 6.3, which only gives me 0.3 millimeters. I actually need a full 9 if I want 3 millimeters. So let's call it 8, and I'll only extrude 2. -2. All right. So for my tensioner back here, we don't have terribly much space between it and the slider, but I guess I'll... Well, either we change it later, or because it doesn't fit, or we fit it in. At this point, so the rubber band's going to go that way. I'm going to just tension it right here on with a T-nut and a small device, which honestly, the small device could just be a flat plate in theory, right? Just assuming there's enough tension. So assuming there's enough tension, it can just be a flat plate, which makes things easy. So let's go ahead and toss that in really quick, just for... So should it be part of the frame or should it be its own component? I feel like it should be its own component. So we'll come up here, new component, tensioner, and this is very simply going to just be a, just a plate with a hole in it for M4 bolts. Project that. Actually, I don't want that one. I want that edge right there, that edge right there. Not that edge. This one right here. And then I also want, I guess, so that's interesting. I don't have my hole in the back right now. Let's hit OK. Come back up here and try to drag these guys forward in time. Okie dookies. And now I want I mean, it didn't necessarily matter. I didn't have to do this, but I want to center it up on these two faces because in theory it should be center of those guys. So that is all my centering information I need. We can go ahead and turn this guy off and that component off. Toss that there. I guess do this. And so that's the funny thing, right? It doesn't necessarily matter here because the intersection, right? Because this is where the bolt's going to go, right? And then this just needs to be centered on that. It's not going to get centered on that, but that can be centered on that. There we go. There we go. And now I can just draw my plate in. This is an M4. Let me just dimension that out really quick, get off my mind. That's an M4 right there. And then for the size of the plate, it's one of those things, it doesn't necessarily need to be as large as the slide. So I don't know. Whoops, not hexagon. I was trying to get line. I don't know if I have any preference on how big it is. Let's see. I think I'm just going to call it 10 here. And then I'll just make it the full size of the extrusion. Actually, I don't need the extrusion to do that. That's just 20 millimeters. I guess I just do, see, this makes me feel better to have this square. It's kind of unnecessary. The alternative here, actually, not even an alternative, a good idea is, let's go ahead and extrude this out. I guess 3 millimeters is fine. But I should probably, as a good idea, as I was saying, toss some alignment pins in here. So I'll grab this guy right here, project out the rest of my body, and project out those two guidelines I have for the T-slot. And use those to place some alignment pins. Grab the center line of this guy to center those guys up. Center that guy up and that guy. And then I'll just go ahead and dimension this as being like 0.5 millimeter, let's say. 0.5. And then we'll make this guy equal to that guy, and we will determine that these guys are like, just make them 3 millimeters. That's fine. Boop, boop. extrude them out. And that's going to be minus like 3, 4. Let's see where the extrusion is at. Yeah, 4 is fine. Alright, there we go. So that is our tensioner in theory. Actually, I should double check that. Let's double check what the distance is between there and there, because we need at least 6 millimeters. As you can see, we do not have 6 millimeters. We don't necessarily need 6 millimeters. It just makes things easier, makes my life easier. Because the rubber band can sit flat. The rubber band is, however, flexible, so it could be curled up. But, again, one fewer thing to wrestle with. So that would be this dimension right here. We're at 5 right now. We want like 6, so that's an extra 2 millimeters. So I'm going to throw 3 millimeters in for good measure. And now we will have at least, it's going to be 6.5, right? It should be 6.5. Yep, math on stream. Got them every time. All right, so there is our tensioner for the rubber band. Now I can stop procrastinating and come back here to the frame. Procrastinating was not strictly correct. I mean, I wasn't strictly procrastinating. I wanted to see where this was going to sit at to decide whether or not I need more space for the bolt. As you can see, I do. Because if I put the bolt... So actually, let me get it drawn. I'm going to go ahead and get it drawn. So we're going to project this guy out and this guy out right here. And again, the rubber band is going to come like this and then come back this way like that. That is not strictly horizontal, it's parallel to that. So this is the path of my rubber band right here. And we need a 3 millimeter. And then we need space to put plastic around it. It needs to have plastic around it. So we need this to fit in this angle right here, tangent to these two angles. Which, as you can see, is a little bit of a problem right now with the size we got. So this is 3 plus 3 plus 3 is 9 millimeters minimum that we're looking at. Actually, you know what? I take this back. I take this back because we actually... My plan was to put this out here on this edge and that edge. This outside plastic, in which case we only need this 3 millimeters in the middle here. So the 3 millimeters in the middle here has to fit in this angle. Now, again, you could do math to figure that out. You can draw yourself a triangle right here, draw yourself a 3 millimeter circle, and then make this tangent like that. And one of those things, triangle, right triangles is everybody's favorite friend. So we'll just do that. So you can sit here. This right here, this so actually, I was going to say the point between these two guys where this goes through here is 3 millimeters. And that I wanted to put on there. There we go. And that guy on... Whoops, not that guy. That guy on there. Now, I guess that... does that make sense? This is tangent to that. I guess the way this is drawn right here... Huh. I was thinking that I'd be able to get the diameter through the center here. But I guess I was mistaken. One of those things, geometry, this is why I'm not doing math on stream. Point being is that you can go ahead and start doing math here, or you can just throw some crap at the fan and make it work. Not have it optimized. So let's just go ahead and do that. What I need right now is just more space in there, so I will just give myself more space in there. Trying to get to sustained flood, and 10 millimeters was not enough, so let's call it 13. And we can come back in here to this sketch. Here's my 3mm. And so one of those things, that's the path of our rubber band around here, so we can put this tangent here, tangent there, and I'll give myself a little bit of just a 1mm buffer here that it has to stay away from this point right here. Okay, so that's where that ends up being. Actually, no, I shouldn't do it that way because this can't move. I was thinking that was going to move, but it is not. This can technically be all the way out to here. So frankly, my dear, okay, next thing to consider is that the rubber band is now pinched between the wall and this guy, which was not my intent. So this actually has to come back here. So the width of this guy is actually dependent on where this ends up being, which I did not realize beforehand. So let me give my 1mm this way then. There's that. What constraint do I got that is keeping me there? Because I should be able to move this up and down this wall right now. What's that tangent? I can't remember what I tangented that to, but what I was going to do was tangent this to the bottom here. What was my intention? Yeah, okay, so I can take this 4mm back because I know that I have a 3mm plus 1mm on this side. I could even take it 5mm out just to give myself a little bit of space in here. So I'm going to go ahead and back up and do that, I think. So let's come down here to the tensioner and redesign this guy. And I'm just going to crop it like this. It's one of those things, I could just get rid of the centering and whatnot and do it that way. But I don't think I want to. So this instead is going to be my 3 plus 1 plus 1. And that's the space around the pulley. Again, I'm not actually putting a pulley on here right now. I should, but I'm not. If I put a pulley on, that's going to take up extra space that I don't want to use. I'm just going around the bolt for right now. So that is where that's going to end up. And then we can come up here rather. And we should be fine now. Actually, we're not fine. Okay, yeah. That's why I had this tangent up here, didn't I? Because the more important thing is that it's pulling tangent to this line. So let me fix that. That was a mistake. However, I do not regret cutting this back because, again, the rubber band has to get underneath this guy anyway. So that needed to happen one way or another. We will go back to being tangent on this guy against that line. Because again, the rubber band has to go tangent from this straight along that path. So that's where we need to place that. So I think that is where we're at. Let me look at this here. All right, so yeah, that is where the pulley is going. Well, at least the shaft. I keep on calling it a pulley again, not strictly correct, accurate, but the shaft. Now, back to our supporting walls, which is a topic we have not been talking about. The supporting walls for this was something we left out at the beginning, and I will come back in and draw them in. And actually, I don't think... Oh, the sketch is up here, isn't it? That is why. I was going to say, I don't see the sketch here for the supporting walls. Here it is. So we will go ahead and do these from each edge. And then we're going to put the hole for the bolt through it instead of drawing this outside circle. So this outside circle, technically speaking, this guy right here, can just be a construction line at this point because I'm not actually going to extrude it because there's no need to, because it's just going to run through the outside wall. So from object and that side. Actually, these are going to be put next to each other, right? We're going to array these across, which means that we want to leave some space so that the bolt and the nut on the other side are not hitting the next one in line. So let's go ahead and do that. And it's one of those things I'm just going to leave myself like, well, I said oh no, I'm using an M3. An M3 is like 2mm bolt height maximum. Maximum may not be the accurate term. It may be like 2.1 or 2, maybe even 2.3. But point being, if I leave myself 3mm, I should be good. So we'll do an offset of 3mm, and that's going to be a minus 3mm. And then a wall thickness of like 3mm is fine. Wall thickness. Now, the one thing here is that obviously that is right up against, it looks exactly against our tensioner. Our tensioner is at the exact size it needs to be, which means that we probably should back this one off because we can't make our tensioner any skinnier in order to have a little bit of leeway in here. And we'll go ahead and hit join and then extrude out that hole in the middle for the bolt. Actually, you know what? I was thinking I was going to extrude that out and then bother. Okay. Never mind. We are going to not use this offset. And the reason is okay. So I'm back to printing, okay? I started thinking about printing again. And this dovetail, first off, is not going to print pretty either direction, whether we print it on the side or face down, is the first thing to note, because the side, it's, just overhang. I mean, it's not terrible overhangs, and we're going to have support if we print on the side. My biggest problem, however, is that this wall on this side is not going to work, which means that it needs to be printed face down like this, so that these walls are vertical. And honestly, the dovetail actually... No, the dovetail still is overhanging there, unfortunately. So, never mind. I was going to say it might be working a little bit better, but it is not. Most definitely is not. So, yeah, I guess that's just where we're at right now. Okay, it's just going to have to be printed this orientation at this point. Okie-dokies. It is what it is. And in that case, if it's going to be printed this orientation, I can put that back in, that offset back in. Cool. Alright, let's go ahead and mirror that across. And the other thing I was going to say is I have an option here to either mirror this wall across and then extrude out the and again, this is going to have to be identical because Adjust and Optimize are not working right now with the relative offsets. My options are to either put the hole in and then mirror both the hole and the construction, or I can just go ahead and do the hole all, distance all, and symmetric all, and then just make sure we're only cutting the frame, which it looks like we are, which is good. I mean, it's very good that we're only cutting the frame because that means that I do have the clearance right there away from everything else. So there is that. Somehow this got off placed at some point, which means that that is not well defined. You were supposed to be concentric. I don't know. Clearly you are on some random point. Oh, you ended up on the origin point, huh? Get concentric, please. There we go. Did we screw up the back too? Nope, the back is right. Alright, cool. Cool. Alright, and the last thing we have to do. Actually, I just realized. You see this bolt placement? That is probably not going to work. Crap. We need 5.5-ish around that. So let's take a quick look at it. $5.5. It's so close. This is for the nut/bolt head. Is about 5.5 on an M3. And you see how it's clipping the front wall there. So, okay, here we go. This tangent right here is not necessary. We can back that out. And then make this guy tangent. So this is my 1mm tangent right here. 1mm plus 1mm plus 3mm obviously is 5mm. 5mm minus 5, or 5.5 minus 5 is 0.5 divided by 2 is 0.25 on either side. So that explains why it was so close, but we can just do this. I'm not going to bother cutting this back, technically speaking. If I wanted this tangent to this circle right here, which is what I did the first time, as ever tangent to this guy, I'd have to redo the math there, but I'm not going to worry about it. It's very slight change, and now we should have enough space for the bolt head / nut to fit in there. And I'm not capturing it only because it's not a mechanical part, it's just a pin. It's only acting as a pin right now. One of those things, I could just get pins, frankly speaking, and then I wouldn't have to worry about the bolt head. And for as often as I do use M3s as pins, it probably makes sense for me to pick up an M3 rod, a 3mm rod rather, not an M3 rod, but a 3mm rod. However, I have not done that yet, so that is the universe we live in. Alrighty. So the very last thing we need to do, which I interrupted myself in with earlier, is getting the micro switch on here. The micro switch, honestly, in this orientation, going perpendicular to the slide right here, at this point, I don't have to cut the tab, honestly. So, that being the case, let's see. I guess what I do is, how do I do this? What is the easiest way to do this? I feel like drawing a sketch and then lining the micro switch up to a sketch is the simplest way. That does seem like the simplest way. I'm just not sure about lining it up horizontally in along the X-plane, how that's going to work out, but I think that's where we're at right now, just for simplicity's sake. So I'm going to do this, grab this wall right here, because this wall is the wall I need to be tangent on. And then I'm going to go ahead and just toss this. That says parallel. I want it to be, so a parallel line with an joined end should be collinear by definition, but just to be on the safe side, I'm going to do that. Change it specifically to collinear. And let me come up here to the micro switch and see what happens when I attempt to align this up here. I want to align that face with that. Alright, it goes perpendicular, which is not what I was looking for. Let's try clicking a different point then. Let's try that. Nope, that's still perpendicular. So I'm imagining if I grab this line and grab that, yeah, it gets me where I want to be. And my only issue is that I'm not centered, which let's see what happens if I do this. One of these things, alignment can be a bit weird. If I click this guy now that we're on that pane and click that guy, nope, that does not, it gives me a rotate option though. Nope, okay. Yep, does not do it. Okay. Okay. So from here, now that I have this lined up on the correct angle here, how about centering this guy with that guy? Not quite. Yeah, not quite. That guy with that guy. Huh. I mean, what I actually need is this point anyway, so I'm technically not getting this right one way or another. I mean, this is the right angle. Don't get me wrong. Actually, is it the right angle? So, it is not technically the right angle. It is not the right angle. Okay. Let's Control Z then. It's not the right angle. So this button, it's one of those things. This button. Okay, fine. Be that way. Try this guy. There we go. In theory, that button's supposed to go down. Obviously, it's not right now. But in theory, about here, which is parallel to this face, is where it triggers the micro switch. So really, this face is what should be parallel. Modify, align. Let's try that. Other way around though. That, and then I've got to move it back like 0.5 is my problem. Actually, let us modify, align. Do this first. Do that. Okay, and then move it back like 0.5 or 1. Move component, micro switch, translate, and not translate, I guess. I want to make sure that it's moving relative to this line right here. Set pivot now. Let us see. Actually, you know what? You know what I can do? So we are close right now. I can just accept it as it is right now. Draw the holes. No, we're not quite there. So let me Control Z. As you can see, so if I hit this and take this, I guess when I line this guy up, which makes sense, it came off on this angle right here, which I'm guessing is 5 degrees. Okay, it says 4.826. Close to 5 degrees. So I actually need to realign these faces like that. Okay. And now what I can do is okay. So it's one of those things. I was going to project all this out, which is one way of doing it. The other way, which would have made more sense, would be to drop this back about 5 degrees and then take the distance from here, because this is the most perpendicular it's going to be. So any forward movement should clear this back face, right? So I should have taken this distance here to, let's say, this here. taken that 14 millimeters and then used that to draw. And then gotten this distance here. Yeah, okay. So let's do that. So I am going to Control Z a bunch of this stuff. And I'm going to come back in here to this drawing here. And this right here, 14 millimeters, that is the distance when the micro switch is compressed, which again is its closest point to this top plate right here. The flange. The closest point that the flange gets to this top plane. 14 millimeters from there to the hole. And now I just need the distance. I screwed that up. Crap. Alright. Finish sketch. I grabbed the wrong measurement. I mean, the 14 millimeters is... I probably could figure it out, but what I really want is this distance to this distance, and then that is degrees. Alright, Control Z, modify, align that guy to that guy. Okay, you are now parallel. I want the distance between the edge here to that guy, which is about 12 millimeters, because unless I didn't get it wrong. If I didn't get it wrong, then okay, it is giving me vertical height, so the 14 millimeters would have worked. Okay, but I need the other measurement I needed, so I need 14 millimeters, and then I need this one here. So 14 and then 15.1, 15.2 I'll say, just because I'm going to put a slot in here anyway. 14 by 15.2, okay. Control Z, Control Z. 14 and then, and actually I can go 14.25, let's say, just give myself some breathing room because the bottom of the slider is going to hit it one way or another. And then from there, all right, so that was that to that. That's the vertical distance, and then the horizontal distance is 15.2. Okay. And there is my 2.5, I think it is, hole. So that's the one, and then I just need to get these distances here. So finish, micro switch, distance between holes. So that's 25.1 on the diagonal. And, well, let me get that in really quick before I forget it. 25.1. And the distance between there and there. Actually, yeah, it does say I'm constrained, which is a little interesting because that one shouldn't be constrained unless I was at an angle. 25.1 is, or was it 25.1? I think it was 25.1. All right, 25.1, and then I can get the offset from the front plane to the center of that circle, which is 2.5. Again, there's a bunch of different ways you can dimension this. This is the way I'm doing it today, which frankly may not have been a great idea, but we live with our consequences. So long as I can get this. So I need Huh. Okay. Let me do this because I'm having a hard time grabbing this distance here. This needs to be perpendicular to that, and then I can do these guys. 2.5. I was having a hard time getting that dimension to pop up on that angle. And I should have checked that this was 2.5 here, which has me a little bit concerned that I clicked the wrong measurement, but I guess I'll find out. So that is a diameter of 3. Okay, so it's actually an M3, and that is 2.5. Okay. Hop back in here. 3 millimeters, and then I'll just delete you, attempt to delete you, and equal you. Alright, there we go. And that is perpendicular to that, right? I think it is. Whoops. Control Shift Z, Control Y. Okay. Perpendicular, I mean this dimension here, because obviously that dimension is pretty close to being horizontal. So, just make sure it was actually measuring this distance here. It kind of looks like it is. .1. I think it might have been slightly off, which is why I redid it. And those are my mounting holes at that point. So, how do I want to... Do I want to mount it two sides or just one-sided? I can't think of a good reason not to mount it one-sided. It just says plastic, so I will just mount it from one side. And in the meantime, and not in the meantime, but while we're doing that, I should probably also extend this guy out to match. So let's go ahead and project out the wall here and extend it. There's that. That is perpendicular. And I don't know why I clicked off it, because I can just come back in here and do this. And now we need to grab you. Let's see. You actually should be. So this. That is right there. That is. Let's see. I guess what I should do is draw this guy here. Put my 2mm wall around that guy. And then match to that. As in go tangent to that. Is how I'm thinking. And I'll make this collinear here. And we can do the same thing over here actually. 2 millimeters to determine how high we're going. Boom, boom. All right. And then you're going to be tangent to that. Okay. And then you want to come straight back tangent. So right angle and tangent to that. And just run into that wall. Again, this is going to be printed in this orientation, so yeah, if this is flat, so long as this right angle is there. It's one of those things. It's a little hard to see because obviously the angle is all sorts of weird right there, but so long as this top edge is perpendicular to this edge, which it is, then we should be fine with printing. And I did tangent, I just realized, to the wrong hole, to the wrong circle right there. So that needs to be tangent to that circle. And now we can... Okay, we can't actually, which is a problem. So because this overlaps now, that means that this is going to run into it wherever I place it. Which means that... Well, what it actually means is that we're going to have to use standoffs on this guy. Is what it actually means. I'm just thinking now at this point, now that I put all this in, I probably should just save on plastic here and trim this down a little bit. Did not want that actually. Fusion, Plux. Control Z. Alright, there we go. So, rather than having these right angles here, these right angles aren't necessary. I should probably just take this tangent here. I'll use them as guidelines, but otherwise cut this out a little bit. And similarly, I can come from anywhere up here on this line, which frankly is probably just here. And so long as this is tangent to, actually just delete that line, I guess, and then redraw it in. Yeah, that can come out there, and then we'll make sure that this connects to that guy right there. That did not work. Okay, Control Z. Alright, keep it simple, stupid. I'm just going to click that dot. And then, point being, this just being tangent here is all I need. So it's got a little bit of an overhang when we print it, because obviously you can see this is more than 90 degrees right here. Right, and we're trying to keep perpendicular to this point right here. But that is a very slight overhang, and therefore I'm not terribly concerned about it. The next thing is back to, this is going to extrude just up here, right? It doesn't need to at this point, actually. At this point, because... Yeah, alright. So at this point, because I just made that an overhang right there, we no longer have that problem of having to do standoffs for the micro switch, because it's no longer interfering with the slide right here. And furthermore, I probably... let's see. So one of those things, it occurred to me, and it's one of those, it's one of those things, it's one of those things, it's one of those things. I could just put it here. I could have just put it here, -3. Okay. And let me just extrude the rest of that to keep it uniform. Two-sided, distance, object, doink, distance, object, doink. Alright, there we go. Now that's uniform looking. But I had plenty of space over here, actually, now that I'm thinking about it. So, I mean, technically speaking, because of these wings right here, or not these wings, these parts right here for the rubber band that keep the rubber band housed in, I probably want to actually do this to this instead. But point being is that I had plenty of space on this side, and the micro switch will bump into the center part no matter what, basically, so long as it's in line. So I probably didn't need to get any kind of fancy to begin with. That's probably just me overdoing it. The micro switch doesn't have to be dead center of the slide. It's not going to be a problem if it's just hitting off on the one corner here. So I probably, again, overcomplicated that. But that is where we're at right now. Yeah, you know what? I don't... It's one of these things. The this line right here. Find that quinkydink. Delete it. We'll go ahead and do that, and then right angle this. That way it is zero overhang at all, because again, it can just be all the way out on the side here. And for good measure, I can even do one better and offset us by a little bit for extra space. Because again, so this micro switch is wide enough that it's going to clip some part of this, which is all we need. We just need one part. It doesn't need to hit dead center. So Again, one of these things, I try not to stream too late. It's after 10, as you can see. And my brain is ready to go to sleep. Okay, modify align. That guy with that guy. Well, not like that though. Yeah, you're gonna be a problem, aren't you? Let's capture position. How do I want to line that up? Huh. So, is this guy... Control Z. Modify align. Is this actually right? Let me do that, and then... It doesn't look like it's right now. But, if I... Modify align... Turn the frame off. You know the biggest problem of this stream so far? I haven't put any colors on this yet. Normally I put colors as I get through them, and I have not put a single color on this model yet. That is clearly a problem here. Okay, no, that didn't keep the same orientation. It rotated me, which is a little frustrating. I wish it wouldn't rotate me, but let's see. I wish I could align to 2 points instead. Let us see. What if I, as built joint, frame off that guy, frame, revolve that guy, okay, and then modify align, micro switch onto that guy. Oh, come on. Alright, quick sanity check. I'm gonna Control Z this really quick. Inspect. That to that is 25.93. And this is not 25.93, this is 25.1. And it's even saying 25.101 now. So that is why I can't align both at the same time. Third problem is that it just occurred to me that micro switch. Let me do this really quick so I can demonstrate. So in theory, that's about right? And that technically, and that not even technically, as you can see, is obviously not accurate right there where that flange is. Again, I was going to put slots in here and I didn't. So that was the next thing I was going to address. So let's go ahead and do that really quick. And this guy right here, the guy that's collinear with that, is going to need to come down. Whoops, Control Z. Actually, that guy is going to have to be parallel with revert position. That guy is going to have to be parallel with that guy, is what it's going to have to be, and then I'm going to have to unconnect him from there. And reconnect him specifically to the line instead. And you... Well, no, not you. But point being is that distance from there, my top of my crossbar, to here, I'll give myself 2 millimeters. So it will be 2 millimeters technically over right now for the impact point. And technically speaking, technically, that's probably just barely enough to get it functional. I probably should just check this. Okay, that's saying, again, for some reason it's really small over here, but that's saying 1.28. So 2 millimeters would be fine there in that case. That's the difference between the inside of the very lowest point of this to the micro switch, which is about where it impacts because it pivots like that. Not specifically saying, but in practical terms. Now I can draw the slots in here. And if we're drawing slots, these are going to end up being construction lines instead. Slots. And one of these things where I got to be real careful about the angle these guys are going on. So first off, I'm going to get that tangent to the hole, so it's the same size of the hole. And then I'm going to set the length of it to be, let's say, 5 millimeters. Swing. We got 5 millimeter swing. And now this I need to be parallel to the slot in there. All right, cool. And that should be good. This tangent line is no longer tangent, so let's get rid of that guy. And back to slot. Not on my quick axis. It's one of those things. They got that quick axis thing. I try to use it every once in a while, but it unfortunately never, because I bounce back and forth between what I'm doing, it doesn't seem to be terribly useful to me. Again, but that may be a problem with me. That may be just I need to get better at doing things in a proper order so that the repeat function is always what I need it to be. But this guy actually can delete altogether. I don't think he's holding anything right now, any important information. But at the same time, I don't know that for sure. So there is that. There's my slots done. And whoops, that is that top part. So we need this guy. Just need to get them available. And there's that. And at this point, I'm not going to... yeah. Modify, align that to that. I'm going to try one more time. Otherwise, it's one of those things I'm kind of beating a dead horse right now. But I'm going to try this one more time, like I said. I'm going to get rid of the revolve because it's not even correct. It was just an attempt on my behalf to get the things properly lined up. They're not getting lined up, however, because that is not correct. Because they're not the same length is my biggest issue. All right, there's that. Yeah, I'm going to leave it there for right now. All right, let's get some colors in here and then wrap up. Plastico. Someday I'll develop some more colors. One of these things, we've only done the slider so far today in this nearly 3-hour stream. I still got to do the, the throttle. The motorcycle style throttle, or slash ATV slash whatever. So point being is that we have another stream coming, is where I'm going with this. So even though I haven't done the flag right here to go on top there, we'll save that for the next stream when we come back. So anyway, like I was saying, let's go ahead and get this polished up. And the mounting, I haven't put so it's one of those things. The holes for the T-nuts, you've seen me do it 1.5 million times before, so it's really not necessary for me to do it on stream. But we will, because we're going to come back here to do the flag, which again, I'm not terribly artistic, so we'll do our best. But that will be a small portion of the next stream, and then after that we will go ahead and do the the throttle for the other piece. So that is this colored, and now it looks pretty. And again, we'll come back and do the finishing touches probably tomorrow morning, so I can start. Well, actually, I'll start printing it tonight because the finishing touches. Actually, I guess if I want to start printing it tonight, I should put the mounting holes in here in the front here. So let's go ahead and do that really quick. It's not quite a 3-hour stream yet, so we have time. And back to front of frame is not really accurate, so I'm not going to call that that at this point. Project that. Project that guy. Draw this in here. Actually, yeah, I can draw this in here. That's fine. Grab the center line of that guy, make sure that he is quinky dink with that guy, and then we can draw this guy in here with our holes. 4mm holes is what we're mounting right now. We have 4, 5, and 6mm T-nuts right now, but the 4mm ones are more than enough. So that's what we're going with. We're gonna collinear that and then center it. And then we just got to decide on a distance for the spacing. And we can do that a couple different ways, obviously. We can go from the edge if we want to, or we can just, determine the distance here. There we go. And I think I'll just determine the distance here and just call it 12mm. Look fine, look fine. I think it looks fine. So there we go. Have our mounting holes. It can now be mounted to the extrusion. Assuming that I click the correct profiles. Doink and doink. Distance all, flipperoni, and object to cut. Only the frame. Alright, and we are off and running. So I can get this printed tonight, get it assembled for you so that you can see it tomorrow morning when we come back, and then we will go ahead and do the flag. And the flag should be the only thing we have to do now because I went ahead and did this guy right here. And it looks like I somehow messed up these guys right here. I'm guessing I screwed those up somehow. I probably projected the wrong line, or when I rearranged things. It might have been when I rearranged things. Tensioner. These tabs are my problem right now. Turn off the frame. And we just keep on going. The stream just keeps on going. That may have just been me being stupid. I don't know what happened there. I actually don't know how I screwed that up. Yeah, that was me being stupid, and I don't know how this is centered up here. Why this is centered. Oh, that is what happened. I know exactly what happened. Okay. So what happened here is we shortened up the top plate. When we shortened up the top plate, that screwed everything up. So this should have, from the start, been centered on this circle right here. Instead, I centered it on this side over here, which is what screwed us up. Actually, from the looks of it, I maybe even screwed up a bit more beyond that. But we're not going to talk about that. The big problem was definitely when I cut down the plate. Definitely. That was definitely it. Okay. Is the stream almost over? Are you guys almost ready to get out of here? I guess so. Boop, 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 boop. Body back on. Alright, there we go. Alright. Yeah, I'll get this printed out. Then we'll do the keycap with the flag on this guy and then move on to the throttle tomorrow morning. So, yeah. Alright. As for other news for the channel, obviously the Stream Deck, as I mentioned earlier, I had an idea of something to do with it, and that is going to slow me down on getting it done because I'm experimenting, which again was not strictly a great idea, but if it works out, I'll be very, very happy. Not a good idea insofar as being productive. Otherwise, we have the, I swear I will get back to it, stream animation program. That is just waiting for pathfinding and basic AI, which again, it should be very simple to put together. I just have to, stream it. So there's that guy. And then the mini CNC machine. Again, CNC in quotes, motion control system, what I prefer to call it, so nobody gets confused that it's going to be like milling steel or anything like that. Definitely not going to be doing that. And I wanted to get that done before I went back to the resin project. So that is in the queue. And then that is probably everything in the near future, only because the other projects that I have planned and that I am forgetting about at the moment, clearly, are lower priority, frankly, than getting this stuff done. Again, the reason I am getting this done right here, what we're staring at, is because that gives me the opportunity, if I do decide that Tooth and Tail is a game I want to stream, that does give me another opportunity to stream games, which is something I haven't been doing because A, time, and B, all these other projects get done. But if I had an excuse, I would stream games, so this gives me that excuse, point being. Yeah, so that is everything that I wanted to throw out there. As always, thank you guys for watching, and I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world, and I will catch you next time.